Hi, Algebra. You're going to learn how to factor two things in this lesson. And they are things that we've actually already done multiplying wise, but now we're going backwards. So let's just get right into it. The first thing is called factoring the difference of two squares. And you might see that abbreviated in some places, D, oh, where's my pen? D, difference of two squares, so dots. So factoring the difference of two squares. Now, what that means is, why is it called the difference of two squares? Well, it means that you have a difference. What's difference mean? It means subtraction. So you're subtracting something. So and I'm breaking this down because you've got to be able to identify these problems or you might get stuck. And so looking for this, having this on your radar is what's going to be helpful. So if you have subtraction sign, that's what difference means. And then of, the difference of, so I'm subtracting what? Two squares. Now, what's a square? A square is a number that you get by multiplying the same two numbers together. So we've made lists of these before, but the 1 times 1 is 1. So 1's a perfect square. 4 is a perfect square. 3 times 3 is 9. Where was I? 16, 25, 36, 6 times 6, 7 times 7, 49, 8 times 8, 64, 81, 100, 121, 144, 13, 169, flip it, 196, and 225. These are your perfect squares that we've talked about. So it means you're subtracting two of those from each other. Now, we have numbers that are perfect squares, but what are perfect squares when we talk about letters? X squared is a perfect square. X to the 4th is a perfect square. X to the 6th is a perfect square. X to the 8th, X to the 10th. Do you see a pattern yet? X to the 12th, X to the 14th, X to the 16th, X to the 18th, X to the 20th, and so on. Now, are 2 and 4 and 6 and 8 and 10 and 12 and 14 and all of those exponents perfect squares? No. But what are all of they? Or what are all of them? They are all even exponents. Because remember with exponents, how do we get x to the, let's say, 20th? We do x to the 10th times x to the 10th because you add, right? 10 plus 10, which gives you x to the 20th. So as long as you can split it up into two equal parts, it's considered a perfect square. So keep that in mind, that with exponents, anything that is an even exponent, it's a perfect square. So even exponents, perfect square. Even exponents, perfect square. All right, so what that means is that we're just subtracting one of these things in the left-hand column and one of these things in the right-hand column of all these things I've listed. All right, let's get into it. So before, we would multiply something like what you have here, x plus 4 times x minus 4. So what we noticed and what I called these were conjugates. I think that was when we were first together in school. Oh my goodness. Okay, so those are conjugates. They're the same thing, but the sign in the middle is different. Same, but sign is different. The sign in the middle is different. And everything else has to be the same. Okay, so when you multiplied those, I don't know if you remember, but we will FOIL these to multiply because that's what you have to do. X times x is x squared. X times negative 4x. Plus 4x minus 16. Well, what happens with those two middle terms? they cancel out. So we get x squared minus 16. That will always happen. We could make up an infinite number of examples. X plus 5 times x minus 5. It could be x minus 3 times x plus 3. So the order doesn't matter of the plus or the minus, right? Doesn't matter because cumulative property, right? Or you could have x plus 2 times x minus 2, whatever. Anytime you multiply anything like this, the middle terms cancel. X squared plus 5x minus 5x minus 25. Boom, gone. This would be x squared plus 3x minus 3x minus 9. This would be x squared plus 2x minus 2x minus 4. And again, those middle terms are always canceling. Like this first one, sorry, I have to write over here, is x squared minus 25. This next one is x squared minus 9. This next one, x squared minus 4. And what do you see here? What is the pattern? These are all perfect squares, right? How do I know? They have an even exponent. And these are all perfect squares because 5 times 5 is 25. 3 times 3 is 9. 2 times 2 is 4. And what sign is in the middle? Difference, a subtraction sign. And so these are all dots. These are all differences of two squares. So they all factor the same way, meaning they all are written, like when we write the factors, in a similar way. They're all conjugates. So anytime you see these, you think, oh, okay, what times what is x squared? X and x. What times what is 25? Negative 25. A positive and a negative. And you go right back to what we started. Those are your factors. So if you have something like this, x squared minus 16, you write your two factors, and you have to recognize, oh, this is a difference of two squares. So I've got my two factors. This is x and this is x, whatever you need to get the first term. Because it's a minus sign, it's plus and minus because it's the difference of two squares. And what times what is 16? 4 and 4. And there you go. Now, can you check your answer? Absolutely. Just FOIL it out and see if you get what you get. All right, so does it have to be the difference? Yes. Now notice, why are these all negatives? Because one of the numbers was positive and one of them was negative. That's what makes the middle term cancel out. So hear me on this. The middle term only cancels when they're the same thing and one's plus and one's minus. See, like all these canceled in the middle. One's positive 5x, one's minus negative 5x. One's positive 3x, one's negative 3x. One's positive 2x, one's negative 2x. That only happens if you have the same number, same coefficient, same variable, and opposite signs. So the only way that happens is if you have plus or minus in the middle. And the only way you're going to multiply two numbers together to get a negative is if one is negative and one is positive. All right, so let's get into it. I think you will be ready for some of these. So this first problem is a squared minus 49. So if you're taking your test and you're asked to factor something like this, you got to say, okay, this is the difference of two squares. It's only two things. And the first thing we always look for is a GCF. There is not a GCF. There isn't a common factor here. It's not a trinomial, so it's not the ones we've been doing. It's just two terms, and so it's the difference of two. Well, I see that it's the difference of two squares because this a squared is a perfect square, 49 is a perfect square, and it's minus. So I'm going to write my two parentheses. I got, a, not x. A, one's plus, one's minus, 7 and 7. And that's it. So quick once you get the hang of it. Now this one, okay, this is also the difference of two squares. Why? Well, because these have even exponents. I hope that sounds familiar because I talked about that on the last slide. So we've got y and y plus and minus m. Now, can you check yourself? Absolutely. FOIL it out. Figure out if the middle terms cancel and if you get the original problem. But that's it. All right, this next one. X squared minus 8. First step, is there a GCF? No, there is no GCF. Is this a perfect square? Yes. Is this a perfect square? No. Because what times what is 8? Nothing. So you can't factor that one. So we would just leave it x squared minus 8, and you can just say it's prime also, or just leave it. Now this one, that's a perfect square. That's a perfect square. But is this the right sign? Not a difference. So guess what? You can't subtract that. You can't figure out what times what. I mean, I know P and P, right? But if you have 4 and 4, that's cool. But what signs are going to go here? If you put 2 pluses, if you did plus and plus, guess what you'd have? You'd have P squared plus 4P. And then you'd have another 4 plus 4P. And you would get the positive 16. But then what do you have in the middle? 8P, which isn't what we wanted. We don't have anything in the middle up there. So this one also cannot factor. There is a way that you'll learn how to later, but right now we can't do that. That's not the difference of 2 squares, not a dots problem. All right, so sometimes it has a common factor, or sometimes it's just a perfect square. And because 1, these were all started with a 1. 1's a perfect square. That works great. But sometimes the leading coefficient, meaning the one in the front, isn't always 1. Like this. Is this still the difference of 2 squares? So what you have to see is this a perfect square? Is 25 a perfect square? Yes. Is m squared a perfect square? Yes, because the exponent's even. Is 16 a perfect square? Yes. So this factors into what times what is 25? 5 and 5, m and m. And then to get negative 16, you could do minus. I'll switch it up, plus or minus, minus plus, 4 and 4. And you could always check yourself, and I'll do it on this first one. 25m squared plus 20m minus 20m minus 16. Those cancel, which is like what we like to see, and that was our original problem. The one over here on the right, 9t squared. Is that a perfect square? Yes, 9's a perfect square. T squared is a perfect square. Is 100 a perfect square? Yes, 10 times 10. Is there a subtraction sign in the middle? Yes. So it's the difference of 2 squares. So what times what will give us those two things? 3t minus 10 and 3t plus 10. Or you can write 3t plus 10, 3t minus 10. The order doesn't matter. 49, z squared. Is that a perfect square? Yes. Is 64t squared a perfect square? Yes. This is the difference of 2 squares. It's difference because there's subtraction in the middle. All right, so we get 7z minus and 7z plus 8t, 8t. Next one, difference, check. Is it of 2 squares? Are those perfect squares? Is 36 a perfect square? Is 49 a perfect square? Are the exponents even? Yes. So it is the difference of 2 squares. 6a plus 7b and 6a minus 7b. So again, noticing all of these factors are the exact same thing. If you look at all of these answers I have boxed, they are conjugates. They are the same thing, except the sign in the middle is different. And that's what multiplies together to give you the difference of 2 squares. All right, so what do we always do first when we're factoring? The first step is always GCF. So is there a GCF in this problem? And you always have to check, and because even though, like, if you look at this first problem, you're like, yeah, it factors right away, but maybe sometimes there are common factors and you have to factor those out first. Otherwise, what you're writing isn't technically correct. So like on this last page, you can look at any of these numbers like 5m and 4 and see, do they have any factors in common? No, 5 and 4 don't share any factors. 3 and 10 don't share any factors. 7 and 8 don't share any factors. 6 and 7 don't share any factors. So like if you were to go over here and do this first and forget this, so I'm going to do it incorrectly over here. This would be 9y plus 6 and 9y minus 6. But look at 9 and 6. Do they have anything in common? Yes, they have a factor of 3. 3 times 3 is 9 and 3 times 2 is 6. So that's a common factor. So technically, that actually is not factored into its prime factors because they share things in common. So you can't do that. So that's why we always got to check first. So let's see. 9 goes into both of those. If you divide by 9 and divide by 9, you would get 9 times 9y minus 4. Oh, I'm sorry, y squared. And then, once you factor the GCF, you always have to check, can I keep factoring? Can we keep factoring? So it's like you're starting all over, that process all over, with just the problem 9y squared minus 4. And yeah, 9y squared minus 4 is the difference of two squares. So you'll have 9, that GCF in front, and then you'll have 3y and 3y and plus 2 and minus 2. And that would be your final answer. So first factor the GCF out. Again, this next one looks like you just go straight into it because 16 and 64 are perfect squares. But we have to check first, is there a GCF? 4 goes into them. Let's see, if we did 4, what would we get? We would get 4k squared minus 16. But, oh no, 4 goes into those too, so let's keep going. Let's see, 16, I guess. 4 goes into them. So that'd be k squared minus 4. And what do you have? What's the common factor? 16 is actually the common factor. If 4 and 4 divide into it, 4 times 4 is 16. That means 16 was the GCF here. So if you actually take 16 squared minus 64, and maybe you knew that right away, that 16 was the GCF. And that's totally fine if you can do that right off the bat. I mean, that's great. But sometimes just always check, do they have any factors in common? Otherwise, that could be what the mistake is if you're not maybe factoring the greatest common factor. You're factoring, like 4 was a common factor, but it's not the biggest one. And then we have to check step 2. Can we keep factoring? 16 times k minus 2, k plus 2. Because that is, this right here is the difference of two squares. You have k squared is a perfect square, and then minus, which is what we need, and then 4 is a perfect square. And don't forget, always write the GCF in front. If you lose it along the way, then you'll never get back to the original problem. All right. Now, sometimes, so we've talked about the difference of two squares. We've talked about factoring when you have a GCF. And we've talked about just factoring when you've got something other than a coefficient of 1. But sometimes you have bigger exponents. Sometimes it's not just about the coefficients being switched up, but the exponents as well. And this is where it was important when I said at the beginning, any even exponent is a square. It can be split in half. Because you add exponents, you can split it in half, which is what's cool about this. So is this the difference of two squares? Is it a difference? Yes. Are these perfect squares? p to the fourth is because 4 is even, and 64 is also a perfect square. So p squared plus 6 and p squared minus 6. As long as I split this in half, it's the same thing. Just like when you had x squared and you split it in half. That is x times x, right? X to the fourth is x squared times x squared. What if you had x to the sixth? That is x to the third times x to the third. X to the eighth. That's x to the fourth times x to the fourth. So you just split it in half. Next one. Is this the difference of two squares? It's a difference, and those are perfect squares. So m squared plus 4, m squared minus 4. Now, does it matter if I do plus first and then minus? Nope, doesn't matter. You can switch